Welcome back to Djji Tutorials. Today we are covering special angles. Let's dive in. Special angles like 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees are specific angles in trigonometry whose trigonometric ratios, sine, cosine, tangent, have exact values that are widely known and used. These angles are crucial for understanding trigonometric functions and solving various problems in trigonometry and related fields. Here's a more detailed explanation. Why are they called special angles? Memorization. The trigonometric ratios of these angles are relatively easy to memorize, making them a foundation for solving problems efficiently. Frequency in problems. These angles frequently appear in mathematical problems and are often used in applications of trigonometry, such as in physics and engineering. Exact values. The trigonometric ratios for these angles have exact values, not just approximate values from a calculator. Foundation for general angles. Understanding the trigonometric ratios for special angles helps in understanding and deriving the ratios for other, non-special angles. Special right triangles. They are related to special right triangles, 30, 60, 90 and 45, 45, 90, which are easy to visualize and understand. Common special angles: 0 degrees and 180 degrees, or 0 and pi radians. These angles have a special meaning on the unit circle, as their terminal side lies on the x-axis. 30 degrees, or pi over 6 radians. This angle is part of the 30, 60, 90 triangle. 45 degrees, or pi over 4 radians. This angle is part of the 45, 45, 90 triangle. 60 degrees, or pi over 3 radians. This angle is part of the 30, 60, 90 triangle. 90 degrees, or pi over 2 radians. This angle has a special meaning on the unit circle, as their terminal side lies on the y-axis. 120 degrees, or 2 pi over 3 radians. 135 degrees, or 3 pi over 4 radians. 150 degrees, or 5 pi over 6 radians. 180 degrees, or pi radians. These are multiples of 30 degrees, or 45 degrees. 210 degrees, or 7 pi over 6 radians. 225 degrees, or 5 pi over 4 radians. 240 degrees, or 4 pi over 3 radians. 270 degrees, or 3 pi over 2 radians, 300 degrees, or 5 pi over 3 radians, 330 degrees, or 11 pi over 6 radians, 360 degrees, or 2 pi radians. These angles are multiples of 30 degrees or 45 degrees and can be found in various quadrants. Why are they important for grade 12 math? Solving trigonometric equations. Understanding these angles helps in solving trigonometric equations and inequalities. Unit circle. The special angles are crucial for understanding the unit circle and how trigonometric functions relate to points on the circle. Trigonometric identities. They are used in deriving and proving trigonometric identities, graphs of trigonometric functions. They help in understanding the shapes and characteristics of trigonometric function graphs. Solving triangles. They are used in solving triangles and finding missing sides and angles. The first family of values refers to the trigonometric functions, sine, cosine, and tangent, evaluated at special angles like 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees, or in radians 0, pi over 6, pi over 4, pi over 3, and pi over 2. These angles are crucial because their trigonometric values are known and can be used to find the values for other angles using reference angles and the unit circle. An example of the first family of values in trigonometry are the trigonometric ratios for the special angles 30 degrees, 45 degrees, and 60 degrees, or in radians pi over 6, pi over 4, and pi over 3. These values are often referred to as the first family because they are commonly used and easy to remember. For instance, sine of pi over 6 equals 1/2, cosine of pi over 4 equals the square root of 2 over 2, and tangent of pi over 3 equals the square root of 3. Here's a more detailed look. 30 degrees, or pi over 6 sine of pi over 6 equals 1/2 a cosine of pi over 6 equals the square root of 3 over 2, tangent of pi over 6 equals 1 over the square root of 3, 45 degrees, or pi over 4 sine of pi over 4 equals the square root of 2 over 2 cosine of pi over 4 equals the square root of 2 over 2 tangent of pi over 4 equals 1, 60 degrees, or pi over 3 o sine of pi over 3 equals the square root of 3 over 2 o cosine of pi over 3 equals 1/2 a tangent of pi over 3 equals the square root of 3. These values are derived from the geometry of right-angled triangles with these special angles, and they are crucial for understanding and solving trigonometry problems. In trigonometry, the second family refers to the trigonometric functions whose values are positive or negative in specific quadrants. Specifically, in the second quadrant, which ranges from 90 degrees to 180 degrees, only the sine function and its reciprocal cosecant are positive. All other trigonometric functions, cosine, tangent, secant, and cotangent, are negative in the second quadrant. Understanding quadrants. The unit circle in trigonometry is divided into 4 quadrants, each representing a range of angles from 0 to 360 degrees, or 0 to 2 pi radians. The cast rule. A helpful mnemonic for remembering which functions are positive in each quadrant is the cast rule. Starting in the bottom right quadrant, or quadrant 4, the letters C, A, S, and T represent the functions that are positive in each quadrant: cosine, all, sine, and tangent. Second quadrant. In the second quadrant, the x-coordinate is negative, and the y-coordinate is positive. Therefore, only the sine function, which is defined as the ratio of the y-coordinate to the radius, and its reciprocal, the cosecant, will be positive in this quadrant. Other functions in the second quadrant. The cosine function, defined as the ratio of the x-coordinate to the radius, is negative in the second quadrant. Consequently, the second function, which is the reciprocal of cosine, is also negative. Similarly, the tangent and cotangent functions, which are ratios of the y-coordinate to the x-coordinate, are both negative in the second quadrant. An example of the second family of trigonometric values refers to finding additional solutions to trigonometric equations beyond the primary solutions. For example, if you're solving for sine of x equals 1/2, you find one solution x equals pi over 6 or 30 degrees. However, the second family of solutions would also include x equals 5 pi over 6 or 150 degrees, because the sine e function has a period of 2 pi and repeats its values. Primary solutions. These are the first solutions you find when solving a trigonometric equation within a specific range, such as 0 to 2 pi or 0 to 360 degrees. Second family of solutions. These are additional solutions that arise due to the periodic nature of trigonometric functions. Since sine, cosine, and tangent repeat their values over certain intervals, there can be multiple angles that satisfy the same equation. Example: if sine of x equals 1/2, the primary solution is x equals pi over 6 or 30 degrees. The second family of solutions is found by using the fact that the sine function is positive in the second quadrant. Another angle with a sine of 1/2 is x equals pi minus pi over 6, which is 5 pi over 6 or 150 degrees. In summary, when finding solutions to trigonometric equations, be sure to consider all the possible angles within a specified range that satisfy the equation, not just the first one you find. This is the concept of the second family of solutions. We hope you find this session useful. Please share with your classmates. See you in our next session.